Welcome to the panel session regarding the technical capabilities of autonomous shuttles. What we have learned from this aspect during the FABULOS project. My name is Oskar Nissi and I will be working as the moderator for this session. And I represent the Metropolitan University of Applied Sciences, and we have been working as the technical partner in the FABULOS project for the past 3 years. And I would like to introduce you to the panelists. First, we have from Estonia, the COO of the Auvetech in the Mobile Civitatem Consortium, Mari-Li Klaats. And from the Tallinn University of Technology, the TalTech, Professor Raivo Sell, also representing the Mobile Civitatem. And then from Norway, we have the General Manager of Forus, Linn Therese Marken in the Saga Consortium. And from Canada, the CEO of Spare, Christopher Wijk Hansen from the Saga Consortium. And then from Finland, from the S4 Shuttle Consortium, the CBO of Sensible 4, Jussi Suomela. And from Spain, from Shuttle, the product manager, Adrià Ramirez, also from the S4 Shuttle Consortium. But first, before I get to the discussion with the panelists, I will go through somewhat about the functional specifications of the FABULOS project, which were drafted in order to get the consortium up to speed and to give us the solution that we were after. So basically, this was our backbone in the definitions and in the throughout the phases that we had in the project. We had functional and non-functional specifications, which were quite usually they were quite together in the specifications as well. And all of these functional and non-functional specifications were based on key learnings from previous robot shuttle pilots that we've had in Metropolitan University of Applied Sciences since 2015. And these real-world pilots actually had shown at the time that there were still some things in the technology that needed to be addressed and still need to be addressed this day. And we used this knowledge to draft sort of the initial idea of what we want from the product. That is the sort of the basis where we start to go to the procurement for the cities. And as a part of the FABULOS PCP project, we had the P0 phase or the open market consultation phase, which is something that precedes all of the other phases in the PCP process. And this open market consultation is a great tool since it has all of the sort of stakeholders from the scene and the industry talking together in an iterative means and way how these questions should be addressed. And we got a really good feedback from those open market consultation rounds. And from that basis, we drafted the first functional specifications that we used. And these functional specifications were divided under 9 topics, and the non-functional specifications were under 3 topics. And all in all, these were divided into about 123 sub-functions. The sub-functions were actually the meat of the specifications, and we used these sub-functions to convey the idea and the things that we wanted from the consortia. They were changed a bit, not majorly, but a bit during the 3-year project, which is understandable. But in the end, we were quite surprised how accurate the initial functional specifications were throughout the project. Some of the things, some of the wordings and some of the technicalities we would have probably formulated, or we would formulate differently, and well, in order to make the sort of process more smooth. And the functional and the non-functional specifications are as followed, and they were quite broadly thematically distributed from fleet management system, starting from the fleet management system, which was mostly like quite top level functionality, going down to the deployment, setup and service, which was really hands-on and a physical thing. And in between we had control room functions and remote operation, which, as the name implies, it says that how should the control room function and how should the remote operation be done. We had a topic of city traffic control, which was actually paired somewhat to the traffic infrastructure integration, which means that how we got the traffic infrastructure communicating with the vehicles and how would the city traffic control work. We had maintenance and incident management, which was quite hands-on stuff as well. What happens if the bus breaks down and these kind of things. And then traffic situation capabilities was actually a bit of an oddball. It was, in the end, it was only something that how does the bus actually react to obstacles. And then the 7 and the 8, the vehicle requirements and the operational requirements were quite much focused on how the vehicle should work, what kind of requirements does the vehicle have, and what kind of requirements does the system have that it can operate in the real life. And in the non-functional specifications, we went for more intangible stuff, such as safety issues and the technical maturity, which means EMC testing, safety equipment, teaching or giving lectures to local law enforcement and rescue services, etc. And the societal maturity is something that we wanted to connect the consortia and the solution to the surrounding society, so including the citizens, including the academia, including all of the things around the solution, which is really important in this mindset. And the third one and the last one was legal maturity. This is actually a very big question. It's a question of the regulation, which has been talked previously. It's a question of insurances and getting all of these sort of paperwork done. And this was there, this non-functional specifications was there to promote the idea that there is also this kind of larger thing going around. But we didn't go through, this project was not so much for the legal maturity, and in this session we will be more focusing on the functional specifications or the technical specifications. So this is where we come from. We come from the functional and the non-functional specifications, and they were rather challenging. The main idea was to push the envelope of the technology, and this is something we heard quite often in the open market consultation, that we something is really hard and really impossible, but we wanted to keep the level somewhere just below impossible because we wanted to actually make the technology go forward, and I hope that we will hear from the panelists how we managed. So I would like to get the panelists on board at this moment. Yeah. So welcome all my friends from the awesome consortia that we have. And I have a set of questions for you guys, and then I would like to first ask, during this Fabulous project or because of Fabulous project, what would be the most critical technical advances that you see that your company and your consortia achieved? And maybe if we start with Marili.
Hello, everyone. First of all, I would definitely like to say that the Fabulous project overall gave us a really high set of requirements and testings that we need to achieve over the years. But of course, during this time, our autonomous stack got better, that we upgrade our overall system and how we manage the buses, and furthermore how we are controlling the vehicles from when all the team members are in Estonia and all the other actual buses are in Greece, that how will we do all the updates, and if there are any bugs or fixes, that how we would actually do it. And we got this all resolved pretty fast, that we could do most of the fixes remotely from Estonia, so we don't actually need to take more people to the actual places. And I think one of the really really technical thing that we actually received is that last spring that we all got our buses or shuttles street legal actually in the most difficult times during the COVID restriction and lockdown. So it was a really strong step from our side that we actually, because of the timeline, that we actually pushed our team forward and worked a lot during the lockdowns, and we got actually our all vehicles all set up for Tallinn and for Lami as well.
Yeah, you could really see the progress in your consortium from the initial prototypes to the product we have now, and you had a really good iterative process there in the technological advancements.
Because I think in the beginning at least we thought we're not going to make it to the third phase because of the bus's readiness, but here we are.
yeah, good that we had. Lynn, what do you think? What was the most sort of technical advancement? What was the most critical thing that you achieved?
We had two pilots that was very different, but we could see that we need to have a large fleet of vehicle and even with a higher level of software to achieve the requirements that you had in the technical requirements. Yeah. And we also experienced that it was a struggle to have this situation with the pandemic and also to start a fleet with public transport. But we managed to do that in Gjesdal in Norway in summertime. And we really had much learning and important learning on how we could implement this technology and these vehicles in this specific area. And we learned a lot of doing operation outside a typical city center in rural areas.
Yeah, and you had a little bit more systematic approach in a way that you didn't have the vehicle manufacturer in your consortium, or you didn't actually create a new vehicle for this pilots. So you had a more holistic approach in the solution.
Yes, that's correct. What we did, we took a vehicle that had been tested before, also in Norway, with the Navia vehicle, and we tried to complete the requirements and to test this vehicle together with the vehicle manufacturer and also to implement the new Saga platform. Yeah. So that was maybe the biggest change compared to the other consortia with their own developed vehicle.
Yeah. Jussi from Sensible 4, how do you see this question? What do you see that was the greatest thing you've achieved?
Okay. Yes. I think there was plenty of things where FABULOS really pushed us forward, and perhaps it's difficult to say which one is the most critical. But I would perhaps raise the issue that we finally demonstrated with 4 different vehicles. Yeah. When we started the project, our aim was to utilize our own gacha bus, multiply it, and use it as a vehicle in all places. But then during the project, we realize and make the decision that the investment to build up the hardware is far too high, and we should just focus the software, which is basically our core. Yeah. And then we finally succeeded to make the pilot with 4 different vehicles, which were the Twizy, which is our oldest test vehicle, then of course the gacha bus, and then we borrowed our customers' so-called CM7 van for the Pasila pilot, and finally in Gjesdal we drive with or are driving still with the Toyota Pro ACs, which are done in cooperation with Toyota.
Yeah. And I have to say, from our point of view, it was really interesting to see, because we had other consortia coming into the project and then dropping one by one during the phases, that how different three kind of sort of consortia we had in the end, and you had different sort of technical advancements, and it was really interesting to read your reports and get the final deliverables, that how Fabulous actually went through. I would also like, one of the big things also was the remote control systems and the teleoperating, and it has been touched previously today, but I would like to also ask, they are still very much under development, and I would like to ask you, how do you see the capabilities of the remote control system? How was it developed during this Fabulous, and was it harder or maybe easier than you expected? And maybe Fraivo, if you would start.
Yeah, hello. I think it's kind of that's a tricky topic, because teleoperation in its nature is actually rather simple issue, because you need the video stream just to transfer like we are looking at the moment, and then you just need to send the control command, which doesn't take much bandwidth at all. So it seems like kind of easy, but whereas the real challenges are like in small details. And of course this network stability. What we learned from this pilot or Fabulous project is that there's the different stability issues were actually the most critical ones. It worked over 4G if the network was good, but on the other hand, in the 3G we experienced really problems with the network, and so basically in the safety concerns we wasn't able to drive remotely. On the other hand, to do this cross-border experiments was quite interesting, and definitely there is kind of big potential to get it work. And so also we experimented the 5G, which is also the main network which should provide this infrastructure for the teleoperation in the future. But again, the network stability, and of course we have right now still kind of prototype networks here in Estonia and also other places. But yes, that was our experience out of this project. So it's definitely possible, it works, but in real cases there are different small issues which actually can eliminate all the functionality. And also maybe the big concern will be the cybersecurity, that you can imagine if someone takes over because of the weak network or weak encryption systems, then that's going to be a very, very big issue in the future anyway. So that's where we need to pay attention, definitely.
And this is actually a good answer, because it highlights kind of 2 points. One of them is that these kind of pilots are quite important to find out the small details that come up only when you go to the real environments in real life. And the other one is that robot buses, more than regular buses at the moment or anything else, or cars or something, they are much more entangled with the infrastructure that is being done, like the cell networks and the positioning, GNSS and everything like that. Adria, do you want to comment on your side, on your behalf, about the fleet management, maybe if not the remote control itself, but the fleet management, and Christoph as well? You're on, yeah. Just a second.
I was on mute, sorry.
Very good.
So yeah, thanks. In our case, the role of shuttle was basically to provide the on-demand management of the autonomous solution, and the fact is that, of course, for providing on-demand management, we already have a fleet manager, which basically answers what an on-demand system might need. And our challenge was to interconnect and see exactly how we could substitute the connection, the usual communication with the driver, to a vehicle that doesn't have a driver specifically. Yeah. And we found that was quite easy, for example, to report the position, because really usually we do have a smartphone or a tablet there reporting as a position, or any SAE, etc. And in that case, basically the autonomous vehicle could report as a position with no problem. We could tell, because we are building the routes, an on-demand system basically takes petitions and desires of traveling from passengers and creates a route based on that. And it was also easy. I mean, a little bit more difficult, but still we could manage to provide information to the vehicle and say, okay, you have to go to stop A and then to stop B and then just stop for 30 minutes. And all that we could integrate in, where we could just simulate as if it was any of our, let's say, common vehicles with common buses with drivers. We just develop a new module that was doing integration. But it was really, really hard here was to simulate the fact that the driver usually says whether somebody's up on the vehicle or not on the vehicle, etc. So when you arrive to a pickup point, you need to really know if that person has jumped in, if there were more people than expected or less. And that was the big challenge that we found. As currently now there is still a safety driver. We saved it by giving a tablet to a safety driver, and the safety driver was doing that role. But I think that's clearly the next step. How can we, through Bluetooth or beacons or NFC or any kind of dynamic mode, to really validate and also allow only those allowed to enter to the bus? I mean, manage payment, etc., etc. That were the challenges.
Yeah, interesting. Christoph, you nodded there for some of the comments. Would you like to continue from that, actually, or add something?
For sure.
Yeah.
Can you guys hear me, by the way?
Yeah.
Okay, perfect. Yeah, I mean, I would just highlight the same thing there, is that, similar to Adria there, we have a fairly mature fleet management system that's deployed many different areas live in operation right now. And I would say that one of the things that we really see as one of the kind of challenges from a fleet management perspective when it comes to autonomous vehicles is those things that you might not necessarily think of first, right? Because everyone thinks of, okay, autonomous vehicles is all about obstacle avoidance, these kind of things, right? In order to make the autonomous driving actually possible. But kind of what Adria mentioned is like the driver has a lot more tasks that it might be harder for us to think about initially than just the driving itself, right? He or she needs to check the tickets. He needs to, provide good customer support. If anyone has issues getting on board, knowing if people have gotten on board, all of these things is kind of, it seems easy when it is, when it's actually human driver. But once you get into the autonomous side of things, all of those things need to be solved somewhat with some kind of technical advance. And that is probably one of the big things that we see going forward, of providing this more human-centered design approach to this environment. So that was definitely our experience, as well as like, how do we know that people have boarded the vehicles? Like something as simple as that from a fleet management perspective. So yeah, it was a very interesting project in itself. And, I'm not sure about the context around this on our specific consortium, but we took a more vehicle agnostic approach, where we really tried to push kind of looking at how can we develop a solution that's agnostic to the actual vehicle running, and really try and mix the human-driven and autonomous at the same time. And based on our experience, I would say that one of the challenges that we've faced is that there's a significant level of maturity challenges, I would say, around API developments from different manufacturers, and the maturity of them at all, right? So that's something that we really want to see going forward, is maybe not, both kind of furthering the maturity of these APIs, but also, more working towards like, how can we actually standardize that? Yeah. And that's probably where, we're probably going to start seeing some regulatory requirements of this, because it might not be completely incentivized by the manufacturer themselves to do that. Yeah. But I'm looking forward to seeing that kind of pushing forward. But that being said, I would say we saw a tremendous amount of achievements being done in this aspect just during this project.
Wow, that is really good to hear. And and your answer actually takes us to a edge of a cliff, and we're looking down and seeing, okay, there's a lot of distance down to travel, and it's interesting to think that, okay, the human is we think it as an easy thing to remove the human from the equation, but your answer actually highlights that it's not. There's a lot of things we humans are quite good of, and we're really flexible and etc. So yeah, it's a daunting task, and I'm glad to hear that things have been progressed, but there's still a lot of work in the standardization, making the APIs sort of understandable and open, for example. And there's also this kind of different mentalities from in Europe. We make these pilots happen with public money, but then when there's for example in the northern America, there's quite a bit of difference in the RDI of these systems, and it's done usually with private money, which means that there's different kind of incentives for the opening of the data and the APIs and such. Jussi, you have been speaking about this remote control and teleoperation previously, and you have some comments on this probably.
Yes, I could say few comments related to that. So, well, perhaps in general, this remote control was something that FABULOS really pushed us forward, because in start of phase 2, we had great plans of our remote control and remote control center. And then we noticed also that it was one of the key things in FABULOS. And on the same time, we noticed that, well, we do have great plans, but we haven't done very much. And that was kind of a start of the real development in the start of the phase 2 of FABULOS project. But yes, if we go to the technology, so I think we realized the issue what Raivo already mentioned, that we can't trust to the stability and bandwidth and latency of the existing networks, and therefore we have been planning the teleoperation in a way that it will not be a kind of a closed loop teleoperation where the operator is really teleoperating the vehicle, but it's more like task-based teleoperation. And we finally now succeeded to test it also. We can include it in the final report, but basically the idea what we tested now is that there is, in a case that there is, for example, obstacle blocking the route, there is the first phase is that the vehicle tries to plan a route around the obstacle, and then if it can do the planning, then it asks from the operator, shows the new route and asks a permission to go, and then the operator will just give a go or no go decision. And then in the next phase, then we also include the possibility that the operator can really plan the route. So basically, draw the route on the map and then give the command to go.
Yeah. So for the viewers, I would like to point out that the terminology is a bit. I don't think it's even very established yet. But the teleoperation itself, like direct teleoperation, usually means that somebody outside of the vehicle has the wheels and the pedals and is driving it like he would or she would drive a car. And then there is this mission-based or task-based teleoperation where you can send missions to the vehicle, and then there is remote control, which usually that means that you're just sort of remotely seeing the vehicle status.
Yeah, typically with the remote control, you have the, let's say, the line of sight to the object.
Yeah.
Not.
Yeah.
Yeah.
So this is a bit for people outside the industry, and even in the industry, there's a lot of variance in the words that are being used, and this is a hot topic. This is something that is not. I see that it's not still solved yet.
Yes, and it might change also, because if we get the fast communications which are basically stable and can provide a very low latency, so it makes things much easier.
And during the FABULOS project, it has actually gone from no teleoperation possible to maybe teleoperation could be a possibility, back and forth sort of as the situation had progressed. But nevertheless, the edge intelligence, which is the AI in the actual vehicle itself, it's quite important so that we can trust that the vehicle is safe in all situations, even if the networks are not working properly. Like we had today a large power outage in Helsinki, eastern Helsinki, that would actually make driving a robot bus quite difficult. Moving on, if we move from the teleoperation, I would like also to see, like, as I mentioned, robot buses are fairly infrastructure related and entangled with the infrastructure. I would like also to hear your points that from the technological point of view, what is the essential support that you guys and your solution would need from the cities and maybe from the authorities? And if we start with Lynn first.
Yes, based on the experience and the complete pilots that we had not only in FABULOS, we see that we have to move towards to have standardized requirements and legislations.
Okay.
And that will be very beneficial and help all the involved parties, especially the local road authorities and the municipality, to have like a guideline or a best practice for the process for testing this new technology on public road in mixed traffic. We would really recommend the municipalities that are planning to have new pilots to seek knowledge and experience transfer from other cities and municipalities and countries. So we are like moving into a lesson learned. And we see that if we have different kinds of requirements when we are introducing this technology, it will be a showstopper for the developing of this technology, because we need to introduce it not only for testing and have real life testing, but we also have to work together with the road authorities and the cities to do so. Yeah. So we know that new upcoming vehicles and software solutions are in the step to increase, and we have to have a legislation to open for testing this on public road and mixed traffic. And maybe we should look into how this could be done in dedicated area that are approved from the authorities. So we can do the stress testing, we can do the experience and learning in a dedicated area. You see today we have new solutions on Norwegian roads that are not allowed to bring passengers on board in Gjesdal. Because the authority needs to have the experience and the data transfer to have this vehicle approved for the next step. So if we have areas with like, for instance, the twin and be able to test technology before we're implemented in new cities, then I think that this will help the authority to improve their role in upcoming projects for future time. So we know that vehicle manufacturers are now very into processing large amount of data and improving capabilities of the vehicle. So, in other words, data is the keyword. So, to get there, to have enough knowledge, enough experience for the authorities and the cities, we need to carry on with the real-life testing. And in the long term, we will have enough knowledge to have this in a commercial operation as a natural part of the public transport.
Yeah. Thank you. I hope all of the city people and authorities were making notes from this answer. Marili, do you want to comment on this? What kind of cities? You have really good communication with Tallinn, city of Tallinn there, and what kind of?
Yes, I definitely agree with Lynn with everything she said about all the legislation part, because I think it's the most time-consuming and sometimes even stopping the project because of the different guidelines in different countries that actually takes so much time, and adapting the new guidelines. That if all the partners or if all the countries have the same guidelines to follow, it would make it definitely way much easier for whatever kind of new technology that wants to be tested or implemented in the areas. So I think this is definitely one of the most helping side that if there would be that kind of guideline. But in technical wise, I think the cities should be maybe more flexible to adapt new technologies. For example, like smart systems, smart sensors that just gather the information, that they actually can share the information between the vehicles and sensor that would make even piloting in or the operating system in kind of some kind of areas more useful. For example, if you're talking about the shuttle buses, we are facing some of the regions that there are blind corners that whatever kind of vehicle you just can't see in behind the corners. So if there would be any kind of sensors or any kind of things that actually gather information and can share it with the vehicles, you would already make the vehicle or the transportation system way more safer and usable in the way wider areas. So I think my call would be definitely that the cities should consider, if they're planning on infrastructure changes or the city plannings, that they should consider using more sensors or more new technologies or smart technologies that would be beneficial in the future wise, if we're talking about the smart transportation system or smart ecosystem. So I think this is definitely the key learning from there.
Yeah, definitely one of the big things in the CCAM, the connected and communicating automated mobility, is that the infrastructure is a big part of it, and the vehicle to infrastructure communication is very important. From the point of view of fleet management technology, would you, our friend from Canada, would you have a point from the other side of the pond?
Sure. Yeah, I mean, I think that there's a couple of things to make this more doable. I would say, just like we have, transit-oriented development right now, I would say that if we actually want to push the autonomous agenda, we need autonomous vehicle-oriented development, right? So it really starts from, the start of planning around the city, right? So obviously that can't do anything about kind of the already built environment, but from the built environment right now, I would just highlight the same thing has been highlighted before. It's really about how can these systems that are already in place, how can they be open up from an open data standards perspective, and so that information can be shared with all kinds of different use cases. And that's not just for our use cases. There's for all of these different use cases that I think is still yet to be explored. I mean, a similarity around this is what we've seen in opening up data standards around opening up data standards around fixed route buses, right? That's something that seemed like it was a small thing, but really it enabled all of this new modern trip planning that we all depend on a daily basis. I think that just a push from the cities and the countries here, I think is really going to be around how can more of this infrastructure data be opened up to be accessible, not only to on the AV side of thing in this virtual room, but to many other interesting new use cases of really figuring out how we can digitize the curb, how we can digitize the infrastructure in general.
Yeah. And from the S4 shuttle side, I will have to give you, either one of you, the possibility to answer this one. Which one would you? Would it be Jussi who would like to give your word?
Jussi, do you prefer to answer?
Okay, I can answer. So, of course, I have to first say that I agree fully to all the previous speakers, and I could also give some examples. So, first of all, the first need is to kind of have unified form for the driving permissions. We have now during the FABULOS project, we have basically applied driving permissions for Finland and for Norway, and in Finland it took 2 weeks, and in Norway it took several months. Also, the amount of paperwork was very, very different between these two countries. Then this open infra is very important. This is not so fabulous case, but we faced in Finland that in Espoo we wanted to have a connection, a vehicle to infra connection to the traffic lights, and in Espoo, in one of our pilots, when we asked, we directly got the API, and here is it, please use it. And then I think that was in Helsinki side, we asked this API for the traffic lights, and the answer was that, well, it's a project to open it for you, and it would cost 20,000, which was then a little bit too much for a short pilot, so we didn't use it that time.
Yeah.
And then, of course, in general, I think the one way to promote the autonomous driving vehicles is to support with the infrastructure in a way, just simple things related to the traffic. So if there is possibility to adapt the speed limits, for example, to the speed limits of the autonomous driving vehicles, perhaps organize a own lane in some places, or give the right of way to drive on the autonomous vehicle route, and this type of kind of a support is used for the driving.
Yeah, very good, and it also shows that these are really complex things. It's not just the technology of the bus; it's everything around it. I will have one more question for you guys, and I would like to have everybody of you to answer, but really shortly, like a really precise answer. I know the question is difficult, but I think you can squeeze it. Based on the fabulous pilots, what is the technical issue or issues, the sort of most compelling? What is the one that should be developed next that would sort of be the low-hanging fruit, or the next biggest step that we can go towards actual service, which we have been talking about the whole day? And if we start from the left top corner from Marili, what is the one thing that you would pick up?
I want to say two. But
okay, two.
One.
Yeah, two. You can.
I think the one thing before actually providing the full service is the scalability, that how we can operate and update many buses at the same time. So if we're talking that the vehicles are around the world, then we're not going to send all the people to just fix something. I think the scalability is the one thing, at least from our side, that we need to deal with next. And of course, the teleoperation capability, because we believe that before we actually can take the operator outside of the vehicle, then all the service idea actually becomes necessary and beneficial.
Yeah. Thank you. Raivo, do you have another one?
Yes, if you talk about technical side, and as our focus is autonomous functions, I would say that there is still a long way to go to make them advanced, fully autonomous driving. If we need to consider that the L4 is meant for like experienced human driver level, then we can see that at the moment just a simple overtaking is challenging for the heavy shuttles. What we can't talk that more complex situation in traffic. So if you really expect that they are 99% autonomous driving and teleoperation is this really, let's say, rare cases, which would make sense, then it's still a way to go. And that's where we are working. And
thank you.
Short answer.
That's a good answer. Lynn, do you agree or have something else?
Yes, I would say, first of all, we need to continue to bring new pilots and new real-life testing to have more learning. And we have to lean towards to have a larger fleet with even higher level of the software, so we can try to find good solutions to reduce the process for doing the programming, to put new vehicles in action in traffic. And also we are pushing it in the right direction when we are talking about removing the operator. But to do so, when we're talking the next level, we need more data and more learning, and projects like this makes it even better for having this collaboration between countries, cities, within this autonomous transport solutions.
Yeah, definitely. Thank you. Adria.
Yeah, I think technologically similar to what we've seen before, or we've said before. Driver with passenger interaction, I think, is the main stopper, at least for us. That'd be it. And of course, more testing, more opportunities to develop it, scaling, that all comes. But I would focus it on that point.
Okay, Jussi.
Yes, of course, there are several things. I don't know, is this the lowest hanging fruit, but at the moment, from my engineer point of view, I would like still to improve the obstacle detection tracking features in the vehicles. We are now able to survive in the most cases in the traffic, but those are kind of the everyday, the easy cases. But then there are let's say the last 10 to 5% of the traffic cases, they are still very difficult for the obstacle detection, and that's something where we put quite much of effort to improve.
Yeah, the right side of the bell curve basically it's the difficult one. Okay, and maybe Christoph.
I would highlight two, one from our side and one maybe from the audiences. So from our side, I would love to see more advances in the API maturity. I think that's kind of an easy way to start us figuring out more data on the vehicles and start doing more large-scale analysis and more large-scale fleet operation. So that's kind of on our side, on in this virtual room side. In terms of the audience, I would highlight one of the comments earlier being just providing fast tracks and in doing this easier from a regulatory perspective. Like, it's kind of foolish to think that it takes months in one country. It tends to be my home country, and then weeks in another country. Many people, I'm based here in North America, and people think that EU is such like a everything is standardized and stuff like that. But this is clearly a place where it just totally disappears. And I would imagine that actually is a big stopper of actually putting it out in many different places, because there's so many different countries in the EU. So if each country has their own, several months to maybe a year in some cases regulatory burden to actually roll this out, that's going to be a huge bottleneck.
Yeah, that is true. Streamlining is definitely needed, and cooperation. I have a few questions from the audience. First one is for Adria. We have a few minutes left. So Adria, you mentioned that you got the position from the smartphone in the vehicle. Was the fleet management system directly talking to the driving stack or any cloud API of the shuttles? Also, how mature was the external mission planning, for example, the dynamic route changes according to the new bookings?
Okay. So first, when we talk with the smartphone, is when we have human driving vehicles. In that case, in fact, what we did was that we had another partner on the team, which was the SoftBank part of Boldly. And basically, they were helping S4 on the remote control. they provided us some APIs, and basically what we was connect to their APIs and get that information. One of the learnings and the things that once we had finished, we already thought that we would have done different, or we would do different the next time, is that we should standardize the ways that we receive the information from the drivers and get to a point as well, that was said here before, become agnostic to the kind of vehicle. So just provide an API point on our side, and then that our driver app or any driverless vehicle connects to our backend system, regardless of who is it or which type is it.
Yeah, thank you. Yeah, there's another question from Alan Thomas, and we're running out of time. So, but I will still push the timetable. I want answer from one of you, and I'm thinking maybe Raivo would be the one. If autonomous vehicles need infrastructure to be made safe for them, that will eliminate the many risk factors for humans. But this has not been done by the road authorities, despite the crashes so far we have with human drivers, who gets blamed. Are we justifying the technology, or is this good as it is? Did you get the gist of the question?
Maybe we can comment more generally. Actually, the next 10, 20 years, we are living actually quite interesting times, because we have to handle the mixed cases where autonomous vehicles and human-driven vehicles have to manage together in the same road. And that's going to be probably a huge problem, because we see simple cases. But let's imagine that, or at least we assume that AV vehicles follow all the traffic rules. But to try to do the pilot, let's say in Hanoi, or I don't know, in Asia, if you follow all the traffic rules, the AV vehicles cannot drive there anyway. Then it raises the question that, okay, if someone crosses the road in the wrong place, shall I somehow warn him, or just I can follow traffic rules, I'll kill pedestrians? So there are really big problems coming in this mixed traffic, that there is the real cases, and all the AVs are going to be servicing as a real public transport systems. And of course, this liability issue is also difficult. That of course, in some sense, it's easier to see who to blame, because we have full stack of sensors. We have 360 degree of view, and then lidars that gives the exact measurements how far, and so. And let's say some cases are probably easier to see who was blamed. But on the other hand, if there is some technology is responsible, so it's very difficult. And who is the manufacturer? Is the owner of the car, and so on. So there are, like you saw also, that it's not only technology, but we have a bunch of problems we need to solve, and especially if we have this mixed traffic conditions in real life. So that's going to be the difficult times, but probably interesting times as well. If you can get the humans out of the roads, then it goes easier again.
Definitely.
Until then, we have to live somehow.
Yeah. Thank you very much. We're running out of time. I want to thank you, all of my panelists, and we have done and seen some fabulous technological advancements throughout the 3 years, but we still have a lot of work to do, both in the technology and everything that surrounds it. I want to thank you from my behalf, and it has been a great project for us as well.